Hello everyone, welcome back to this channel. This is Professor Rajesh Barapti, a book author of 25 plus engineering books. Dear students, today's topic is conversion of number systems. Earlier, I have created one video related to basics of number systems. If you haven't yet watched that video, do watch it. I will provide the link in the description box. I would like to brush up few things related to number systems. There are four major number systems. First is decimal number system, whose base is 10 and the numbers 0 to 9 are used. Second is the binary number system, whose base is 2 and numbers 0 and 1 are used. Third is octal number system, whose base is 8, numbers 0 to 7 are used. Fourth is hexadecimal number system, whose base is 16. Actually, the base is 16. That means I am supposed to use the numbers from 0 to 15. But in this number system, the numbers from 0 to 9 are used. Do remember, it is 0 to 9. That means total 10 numbers we are using. Whereas for remaining numbers, like we have to cover the numbers till 15. So for remaining numbers, letters are used. For example, for 10, letter A is used. For 11, letter B is used. Similarly, for number 15, letter F is used. So this is the hexadecimal number system. The very basic question arises, why we should learn this conversion of number system. Very simple application I will tell you. In case of mobiles, laptops and in digital technologies, the binary number system is used where only two digits, zeros and ones are used. But we are habituated of working in decimal number system. So for performing any kind of application, we need to convert decimal number system into binary. After completion of that application, for the end user, result must be displayed, but end user can't understand the language of binary. So again, the things from binary should be converted into the decimal number system. So this is just one simple example where the conversion of number system is used. Likewise, there are n number of other applications. I have divided this topic into two parts. This is part 1, in which I will cover the hub portion of conversion of number system, whereas in the second latter part I will cover the remaining portion. What is this conversion? If I am talking about decimal number system, I have to convert decimal into binary, then decimal into octal, decimal into hexadecimal, and so on. Likewise, any number system can be converted into the remaining number system. Actually, we can expect the numericals related to this conversion of number systems. The first type of conversion is binary to decimal conversion. Before starting any conversion, let us brush up one more concept. Suppose I will write this number 356.12. Everyone is aware this is known as decimal point. The bits before decimal point is known as integer part, whereas the portion which is after decimal point, that these digits 1 and 2, is known as the fractional part. So there are certain rules for integer part and fractional part. Let us consider one example in which we want to convert binary number into the decimal number. As an example, I am considering the number which is a binary number. It is 10110.0101. This is just one example. Actually, in the exam, you can expect the question like this. This number will be given like this. Bracket will be given and base 2 is written. Just by referring the base, you can easily identify which type of number system is this. So presently, it is a binary number system. We have to convert it into the decimal number system. How to make this conversion? This is the decimal point. Keep decimal point as it is. Every bit is to be multiplied by some power of 2. Why power of 2? Because we are talking about a binary number. The base of binary number is 2. Make the thing simple. The digits which are just before the decimal point, multiply it like this. This is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. If there are again more digits, we would have written 2 raised to 6, 2 raised to 7 and so on. Very simple. Consider decimal point. Before decimal point, go on writing these powers up to 2 raised to 0, 2 raised to 1 and so on. After decimal point, the powers are negative, like 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4, and so on. Now, remaining part is, this is called as weighting multiplier. Now, remaining part is, every digit, like this is the decimal point, this 0 is multiplied with 2 raised to 0. So naturally 0 into anything is 0. This will produce 0. I'm just talking initially for the portion which is integer part, which is just before the decimal point. Then this number 1 is to be multiplied with 2 raised to 1. 2 raised to 1 is 2. So this answer will be 2. This number 1 is again getting multiplied with 2 raised to 2. 2 raised to 2 is 4. So this answer is 4. This number 1 is getting multiplied with 2 raised to 3. 2 raised to 3 is 8. So this answer is 8. This 0 is getting multiplied with 2 raised to 4. Same logic. Whenever 0 is there, directly write answer 0. Because 0 into anything is 0. This number 1 is getting multiplied with 2 raised to 5. You can well calculate these higher values on the calculator. So 2 raised to 5 is 32. So I have done this conversion. Similarly, consider the portion which is after the decimal point. This 0 should be multiplied with 2 raised to minus 1. So naturally, this result is 0. Next, this 1 is getting multiplied with 2 raised to minus 2. Simplify it on the calculator. So it's very simple. 2 raised to minus 2 can be written as 1 by 2 square, which is 1 by 4, which is 0.25, and so on. So likewise, you can make the conversion. Then the 0 into 2 raised to minus 3, it becomes 0. Likewise, convert this number 1 into 2 raised to minus 4. So it is 1 into 2 raised to minus 4. It is 1 by 2 raised to 4. So it is 1 by 16. So this is 1 by 16. Now, what you are supposed to do, add all the values, whatever you got after multiplying, add all the values before the decimal point. So this represents the integer part. Keep in mind, integer part and fractional part should be calculated separately. So I am talking about the integer part. So add all these values. So it becomes 46 point. Again, add all these values. You can well make use of the calculator. So this answer will be 3125. Final answer is to be written like this. Write down this answer and write it as a base 10. In the exam, you will write this given number. I mean, how to generate, how to write the answer directly. 1011110. This number I am writing it as it is 010. This was the given number whose base is 10, which was binary. Write the answer like this. You have converted into decimal. Final answer is 46.3125 base 10. Base 10 represents it is a decimal number. The next type of conversion is decimal to binary conversion. So let us consider one question. Suppose question is like this: 428.10 bracket close, base of the bracket is 10. It means the given number is decimal, and it is asked like this in the bracket question mark base 2. That means we have to convert this decimal number into binary. How to do it? Actually, there is some different procedure compared to the earlier part. Consider integer part separately and decimal part separately. This is the integer part, which is the part before the decimal point, which is 428. Now consider this number 428, divide it by 2. Why divide it by 2? Very simple. I want to convert it into binary. Base of binary number system is 2. So divide it by 2. Now I will make two columns. One is quotient and another is remainder. So after performing this division, you are going to get the quotient, that is answer of this division. This is the perfect division. So answer of this division is 214 and remainder is 0. You can well do it on the calculator. Next, consider this part, that is 214 divided by 2. Again, this is a perfect division. So answer is 107. There is no remainder, so remainder is 0. Now consider this number 107, divide it by 2. Now do it on the calculator to make the thing simple. If you divide it using the calculator, then actually this answer is 107 by 2 is 53.5. So make the thing simple. Write this 53 as a quotient What is the number after decimal point? It is 0.5. Multiply it by 2. Presently, this is the simple technique, but do be habituated of working like this. You are getting 0.5. That means number 5 after the decimal point. Multiply this value by 2. So answer is 0.5 into 2. That is 1. So remainder is 1. Next, consider this number 53 divided by 2. So answer will be 26.5. So quotient is 26. You are doing it on the calculator. Answer is 26.5. Quotient is 26.5 into 2. That is 1. So remainder is 1. Next, 26 divided by 2. I am considering this number written over here. Answer is 13. This is a perfect division. So remainder is 0. Now 13 divided by 2. Answer is 6.5. Quotient is 6. Remainder is 0.5. That means 1. 0.5 into 2 is 1. Then consider this number 6 divided by 2. Answer is 3. This is perfect division. So remainder is 0. Consider this number 3 divided by 2. Answer is 1.5. So quotient is 1. Again, since it is 1.5, 0.5 into 2. Remainder is 1. Now consider this number 1 divided by 2. Actually, this is not a perfect division. You are getting on the calculator, you are getting answer 0.5. So quotient is 0. You can well mark dash over here if you are getting quotient 0. And since you are getting remainder 0.5, so a number after decimal point is 5. So remainder is 1. That means 0.5 into 2 is 1. So that's it. Up to this step, I have done the calculation. Do remember, I have considered only integer part. How to write this answer? Don't do the common mistake. If you perform the division for integer part, be habituated. I mean, make this as a rule. Write the answer from bottom to top like this. You will have to write the answer from bottom to the top. This is because the last number after division represents MSB, whereas this number represents LSB. So how to write the answer of this part? I have just completed one part, that is the part related to integer. Write the answers from bottom to the top. So it is 1 1 0 1. I am writing it in reverse way. 1 1 0 1, then 0 1 1 0 0. So it is 1 1 0 1 0 1 1 0 0. This is the answer of integer part. Now for the fractional part, the rule is slightly different. Do remember it like this. What we did for the integer part, we have divided every time the available number, that means quotient, by 2, and we have just written the remainder part, and we have collected all the remainder parts starting from bottom to the top, and we have written the answer of integer part. Now consider the fractional part. How to do the calculation for fractional part? It is 0.10. This fractional part is 0.10. Multiplied by 2. Do remember like this. For integer part, I have divided the number by 2. For fractional part, multiplied by 2. So if you multiply it by 2, answer will be 0.20. So it is 0.20. There is no integer part. See, this is the decimal point. There is no digit before decimal point. It is 0. So I will write this column as carry. I will have to go on writing the carry. So carry 0. If you are getting 0 over here, directly write carry 0. Then consider this number 0.20. Again multiplied by 2. Answer is 0.40. You are getting 0 before the decimal point. So carry 0. Then again 0.40 into 2. Answer is 0.80. Again you are getting 0. So answer is 0. Then 0.80 into 2. Answer is 1.60. Consider this number as you are getting some number before the decimal point. So this is the carry, which is 1. In this case, carry is 1. Now skip this one. What is the remaining part? 0.6. So now multiply 0.6 by 2. Answer is 1.2. Again you are getting something as an integer part. So write the carry as 1. Keep in mind, we are dealing with binary number system. So this carry must be in terms of zeros and ones. Now again you have written this carry as 1. Remaining part is 0.2. So multiply 0.2 into 2. You are getting 0.4. Again you are getting 0. So write this carry as 0, and so on. The question arises, up to which stage I will have to go on continue this calculation. make it as a rule. Actually, ideally, this calculation should be continued till you will get a after multiplication you will get fractional part equals to 0. But in practical cases, up to 4-5 stages of iteration you can do it. That means 4-5 times multiplication is sufficient from the exam point of view. Now what we did in the integer part, what I said, in case of integer part, write all the things from bottom to top in fractional part. This is the fractional part. Do it in reverse way. That means write all the values from top to bottom. So this number from top to bottom is actually 0, 0, 0, 1, 1, 0. It is 3 times 0, 1, 1, 0. So final answer can be written like this. This answer I have already written for integer part. The fractional part is this answer. So after this decimal point, write it like this: 0, 0, 0, 1, 1. This 0 even you can skip it because it is after the decimal point. It has no meaning. Close the bracket and write its base as 2. So this is the procedure to convert decimal number into the binary number. Next type of conversion is octal to decimal number. Now don't get confused. There are so many types of conversions, so you need to remember it logically. How to remember it? What we learned in case of decimal to binary to decimal conversion. What we did in case of binary to decimal conversion, whatever points were there, whatever digits were there before decimal point, we multiplied by 2 raised to 0, 2 raised to 1, 2 raised to 2 and so on. The digits after decimal point, we multiplied it by 2 raised to minus 1, 2 raised to minus 2 and so on, because it was binary. This is octal. We are converting octal number to decimal number. So in case of octal number, the base is 10. Now how to do it? I will write the number separately for the simplicity. It is 246.28. This is the given octal number. This is the decimal point. Keep it as it is. Now similar to the case of binary, since base is 8, I will multiply this number by 8 raised to 0, next is 8 raised to 1, next is 8 raised to 2 and so on the left hand side. Then at the RHS after decimal point, this is 8 raised to minus 1, 8 raised to minus 2 and so on. The procedure is exactly similar. So perform this multiplication. Every time go on multiplying the values like this. So it is 8 raised to 2 is 64. 64 into 2 is 128. Then it is 8 raised to 1. 8 raised to 1 into 4 is 32. This is 8 raised to 0. Something raised to 0 is 1. 1 into 6 is 6. Point. This is 8 raised to minus 1 into 2. So it can be written as 2 by 8. That is 1 by 4, which is 0.25. So it is 0.25. Then this is 8 into 8 raised to minus 2. This is 8 into 8 raised to minus 2. That is 8 divided by 8 square. So it is 1 by 8. So it is 0.124. So this is the way how you can perform the multiplication. Now simple like the previous case, add all the values which you will get after performing this operation. One more thing, this is a 0.125. So what I said, first I will write this number 0.125. So perform this addition. So this answer will be 166. Keep decimal point as it is. Point. Again add these values which you got after the decimal point. So this is 0.375. So this is the final answer. You will be writing the final answer like this. Write this answer in the bracket 166.375 to the base 10. That means you have converted octal number into the decimal number. The next type of conversion is decimal to octal conversion. It is similar to the previous case, like we converted binary number. So how to do it? Consider integer part separately. So integer part is this number 175. I will write it over here. Integer part is 175. Do remember we are converting it into octal. What we did while converting decimal number into binary, every time we have divided the number by 2. Here the conversion is from decimal to octal. So divide it by number 8 because it is the octal whose base is 8. So I will write it like this: 175 divided by 8. Do it on the calculator. On the calculator, you will get answer 21.875. So this is the answer what you are getting on the calc. Now write the quotient part. I am writing Q for quotient part. Then write one more column, remainder part, that is R. So quotient part is 21. Skip the decimal part after decimal point. So quotient is 21. Now similar to the previous case, this number is 0.875. Since it is octal, multiply 0.875 by 8. So if you do this multiplication, so answer will be 7. This is the remainder part. Now consider this quotient 21. I will write it over here for the next calculation. So it is 21. So next will be 21 upon 8. Again you will be doing it on the calculator. So answer will be 2.625. So quotient is 2. What about remaining part? Like the previous case, 0.625. I will write it over here. This is the remaining part into 8 because this is the octal number. So perform this calculation on the calculator. So answer is 5. This is the remainder part. Now consider this quotient 2. So again perform 2 by 8. So if you do it on the calculator, you are not getting any, you are getting answers in terms of points. So what you are supposed to do, write this part as 0 because you are not getting any quotient. In place of quotient, I am writing this part as 0. And after performing this 2 by 8, this is 2 by 8, that is 1 by 4. So it is 0.25. Then this number 0.25, since I am getting no integer value, I have written 0 at the quotient. Here you can well mark the dash. Now number after decimal is 0.25. Multiply 0.25 by 8. So answer is 2. Consider this as a remainder. That's it. So you have completed this calculation for the integer part. Now similar to the earlier case, what we did for integer part, go on writing the answer from bottom to top. This is the rule for all integer values. Write the answer from bottom to top like this. So answer is 275. I will write it over here. So answer of integer part is 275 point. Now I have to convert this remaining part, that is decimal part, into the octal number. Again the procedure is same like that of conversion of binary. Now this number is 0.23. What we did in case of binary, every time we multiplied it by 2. In this case, multiply it by 8. So after performing multiplication, answer is 1.84. You are getting number 1 before the decimal point. So like the next column as carry. So I will write carry equals to 1. Whatever number you are getting before decimal point, write it directly as a carry. Now consider only portion after the decimal point. That means consider only fraction part. So write it like this: 0.84 into 8. I can perform this calculation on the calculator. Answer is 6.72. So you are getting number 6 before the decimal point. So carry 6. Then perform 0.72. Skip this 6. Perform 0.72 into 8 on the calculator. So you will get answer 5.76. Since you are getting number 5, write this in the column of carry. Now consider this number 0.76 into 8. So this becomes 6.08. Now you are getting number 6. So write it like this. Up to 4 points, that is sufficient like the previous case. But this is the fractional part. So you should write the answer from top to bottom. Very simple rules. When you are doing calculation for fractional part, whatever carries you are getting, write it like this from top to bottom. So it is 1656. So final answer I will write it like this: 1656. And base of this answer is 10 because we have base of this answer is 8 because we have converted decimal point in decimal number into the octal number. The next conversion is octal to binary conversion. To make the thing simple, I will tell you one trick. Octal numbers base is 8, so numbers are 0 to 7. Do remember this table. It's very simple. Actually, we did this calculation in the earlier video. How to remember this table, I will tell you directly. There are 8 numbers 0 to 7. So write it like this. 3 bits are required to represent 8 number. How come? Because we know that 2 raised to 3 is equals to 8. So there are 8 numbers, so 3 bits are required. Start from 0, 0, 0, then 0, 0, 1. It's very simple trick to remember this table. Look at the last bit. Go on writing alternately 0, 1, 0, 1, 0, 1, 0, 1. Then second column, this column. 2 times 0, 2 times 1, 2 times 0, 2 times 1. Next column, this column. 4 times 0, 4 times 1, and so on. That's it. If you know this table, conversion is pretty simple. Suppose I want to convert this number. This is the given number, which is an octal number. I have to convert it in terms of binary. Make the thing simple. First digit is 3. For 3, check the table. Binary equivalent is 0, 1, 1. So I will write for 3, it is 0, 1, 1. Next number is 5. For 5, it is 1, 0, 1. For 2, number 2, it is 0, 1, 0. Keep decimal point as it is. For 5, again it is 1, 0, 1. Then for 6, it is 1, 1, 0. For 3, it is 0, 1, 1. That's it. Close the bracket, write its base as 2. So this is the simple technique. If you know this table, you can well convert any octal number into the binary equivalent number. Now, in this part of video, the last part is binary to octal conversion. As I said, this is part 1. Remaining part I will cover it in part 2. So binary to octal conversion. Suppose this is the given number which is in the form of binary. I will tell you the simplest technique to convert it into octal number. Make a group of 3 bits. How to do it? Consider the points before the decimal. Consider the bits before the decimal point. So I will have to form the group of 3 like this. So start from this right to left. So this is the decimal point. So first group I will write like this 0, 1, 1. I have started from right to left. This is first group. Second group is this 1, 0, 1. So I will write second group over here 1, 0, 1. So every time you have to make a group of 3. Suppose now this is a perfect group because there are 6 bits before the decimal point. Suppose the given bit is again one more bit would have been given, say 1. So after making these 2 groups, only 1 bit is remaining. How to make a group of 3? Make the thing simple. Add whatever number of zeros required. So if 1 would have been given, I would have written the next group as 1, 0, 0. Even though these 0 zeros are not given, you can add any required number of zeros. Okay. So presently this is the perfect group. Now mark decimal point as it is. After decimal point, again start forming a group of 3 which is after decimal point. So first 3 bits are 1, 1, 1. I will write it over here 1, 1, 1. These are the first 3 bits. This is one group. Second group is 0, 1, 0. 0 was 0, 1, 1. Suppose one more bit would have been given like 0. Then only 1 bit is remaining. You have to make a group of 3. So again, like the previous case, add 2 zeros and so on. Now after writing it separately, do remember this sequence. From right to left, the multiplier values are 1, 2, 4. Very simple trick. From right to left, multiplying values are 1, 2, 4. Below each digit, go on writing this multiplying factor, that is 1, 2, 4. So it is 1, 2, 4. Below this group, this is one group, this is second group. Below this again 1, 2, 4. Decimal point as it is. Below this group again like write 1, 2, 4. Below this last group again write 1, 2, 4. Do remember I am writing it from right to left. Now remaining part is very easy. Multiply every bit by the corresponding multiplying factors. For example, 1 into 4. So this answer is 4. 0 into 2 is 0. So I will write 4 plus 0. 1 into 1 is 1. This is answer of first part. Plus 0 into 4 is 0. 1 into 2 is 2. 1 into 1 is 1. Decimal point as it is. Again 4 into 1 4. 2 into 1 2. 1 into 1 1. Plus 0 into 4 0. Plus 2 into 1 2. Plus 1 into 1 1. Now add all these values. So final answer will be, this is this is 0 plus 1 actually. So this is 5 plus 3 point, this is 7 plus 3, so it is 8.10. So final answer is 8.10 at a base 8, because we have converted binary number into the octal number. So the final answer I have got is 8.10 to the base 8. So this is the way how you can convert any binary number into the octal number. Dear students, as I said, this is part 1. The remaining conversion I will complete it in part 2. So that's it for today's session. Thanks for watching this video. Thank you very much.